So for 5-4, we're looking at what we call exponential growth and decay. Now, in real life, we can actually model a lot of different things in terms of exponential functions. It's exactly the same as the exponential functions we've been working with so far. What type of exponential function do you think growth is? Increasing or decreasing? Increasing. It's increasing. So if we say exponential growth, that's the same thing as saying an increasing exponential function. What about decay? What would decay be? Down. Decreasing. So it's just another way of saying that the function is increasing or decreasing, okay? We can use exponential functions to actually model the graph, and we use the exact same format for exponential functions that we have been using already. Y equals a times b to the power of x. So I want you to highlight that and then put a box around it. This is the function family, the general function for the exponential function family. A times b to the x. A, b, and x always stand for the exact same thing, just depending on the problem, depends on what we plug in. A represents the initial amount, so highlight that for me. Initial amount is the amount that we start with. B represents the growth or decay factor, which we've been doing already. The only thing we have to pay attention to is, since I will be doing exponential growth and decay, that's usually by percentages. So let's say the population increases by 25% every year. If I plug in 0.25 for B, that means that I'm taking 25% of the initial amount. That's not exactly what I'm asking though, right? I want to know what it would end up being if I increase by 25%. So multiplying just by 25% tells you the exact number that we increase by. Does this make sense? Mm-hmm. So to avoid having to do each one individually and then adding it to the previous term, we can put in the growth factor as 100% plus the percentage rate of change. Adding by that 100% is saying we're finding the 25%, and then plus 100% means that we're adding it automatically to the initial amount. If we are decaying, what would we be doing? Subtracting. So it would be 100% minus the percent rate of decay, okay? So when we're plugging in our B, we have to remember that you need to either add or subtract from 1. X is the number of times the growth or decay factor is applied. So how many times I'm multiplying that number by itself. And then Y represents the result of applying the growth or decay factor. So it's your answer. Okay. So those are all the important pieces. They're going to do a problem for us. So let's look at a problem. A gym currently has 2,000 members. I like to underline the important information. It is expected to grow 12% per year. Okay, really quick. When we're plugging in 12%, do I plug in 12 or do I have to change it? Change it to a decimal. 12% is the same as saying 12 over 100. So what would that decimal be? 0.12. How many places do you move the decimal over? 2 places every time, okay? So make sure that you don't forget to do that. How many members will it have in 6 years? So the very first thing they want us to do is identify the A, B, and X, and then solve. There are 2,000 members to start, so A equals 2,000. The growth per year is 12% or 0.12, but B, since it's an increasing, we add it to 1. So 1 plus 0.12 or 1.12. The desired time period is 6 years, so X equals 6. And then we just plug all of that into the function. So we get Y equals 2,000 times 1.12 to the X. We already said X equals 6. So Y equals 2,000 times 1.12 to the 6. And then they rounded it to 3,948 in 6 years. Okay. When we do the practice problems, I'll remind you how to plug all that into the calculator. Okay. So let's look at exercises 1, 2, and 3. I'm going to do one of them with you, and then you guys are going to do the other ones on your own. Number 1, when a new baby is born to the Johnsons, the family decides to invest $5,000 in an account that earns 7% interest as a way to start the baby's college fund. If they do not touch that investment for 18 years, how much will there be in the college fund? If we are investing and we don't touch it, that means it's growing, so this is an exponential growth problem, right? Okay, so what is A? What is the initial amount? 5,000. B is the growth rate. Now, we're growing 7%, but since it's an exponential growth, remember we have to add 1 so that we don't have to do all the addition individually. So 1 plus 7% is 0.07. So your B is 1.07. And we won't touch it for 18 years, so X equals 18. So let's plug all of that into the exponential function. Y equals A, 5,000, times B, 1.07 to the 18th power. Okay. Can you see your calculator really quick? Guys, how do we plug this into the calculator? In order of operations, what comes first? Yeah, we need to take care of the exponent. So you have to do that 1.07 to the 18th first. Do not round until the very, very end. So what you're going to do is you're going to plug in 1.07. That's the base, right? X to the power of y. That means that we want to turn it into an exponent. So you press that. And then you put in the exponent that we're plugging in, 18, equals this whole thing. Don't round it yet. Then we multiply by 5,000. So times 5,000 equals all of this. So that's going to be 16,899 and 66 cents. They didn't tell us to round, but does it make sense to include the cents in there as well? Yeah, so we can leave it as this. If they asked you to round to the nearest dollar, that would be this one right here, right? And so we look at the next term, which is 6. Does that 6 round up or down? Up. So that changes that 9 to a 10. So we have to carry 1 over, which changes this 9 to a 10. So we carry it over, and we would get approximately $16,900. Either of these answers I would accept. You do have to round correctly, though. If you leave it as 16,899, you did not round. So you can't just take the cents away. Okay? Yes, I did. Thank you. Okay? Either one of these I would accept unless the problem specifically asks to round to the nearest dollar. Okay? So if it specifically asks, then you have to round. All right, so what I want you guys to do is look at numbers 2 and 3. First, you need to figure out if it's an exponential growth or decay problem. But you guys work on it with your neighbors, and then we will check the answers in a few minutes. All right, number 2, the local animal rescue league is trying to rescue the number of stray dogs in the country. They estimate that there are currently 400 stray dogs, and that through their efforts, they can place about 8% of the animals each month. Guys, is that a growth or a decay? Decay. That's a decay, because they are reducing the number of stray dogs on the streets. How many dogs will remain in the county 12 months after the animal control has started? Now, I just want to know what A, B, and X are to start. So what is the A term or the initial value? Who's 14? 1-4. Kevin, what's the initial value? The initial value is 400. Good. Okay. Then B is our decay rate. Now, in my decay rate, that means I'm going to be adding to 1 or subtracting from 1? Subtracting. Subtracting. So it's going to be 1 minus what? Who's 37? No one. Who's 5? Ernesto.
.08.
1 minus 0.08, so what did you get for B?
0.92.
0.92, great. And then X is the amount of time that is going to be passing, so what's our X? Who's 26? Oh, she's not here. 25, Kelsey. For X, 12. Did anybody put 1 out of curiosity? You're thinking about it? Why would we keep it as 12 and not 1?
Because it goes for each month.
Yeah, because the rate is 8% for each month, and then we have 12 months, so our units match, right?
So if you put it said each year.
Yeah, so if I put that we are decreasing the amount of dogs by each year, and I put 12 months, you would plug in 1. So your units have to match. Okay, so when we plug that in, that should be y equals 400 times 0.92 to the 12. Okay, so when you plugged all of that in, how many dogs do we end up with after 12 months? Who's 34? Dimitri, how many dogs do we have left? 253. Agree, disagree? Disagree. Somebody that got something different. Maddie? 147. 147. Oh, so Dimitri said he did get 147, but then he thought you had to subtract that from 400. Why do I not have to do that?
Because you added the 1. You minus the 1.
Because I subtracted the 1. So doing that 1 minus the percent keeps you from having to do that. Remember, y is equal to, and we highlighted it, the result. So whatever you get after you plug it all in, that's your result. Okay? So you just stop there. Okay? 147 dogs. Because we can't have part of a dog, right?
Yeah.
So it should have made sense to round. Okay, number 3, a basket of groceries costs $96.50. Assuming an inflation rate of 1.8% per year, how much will the same basket of groceries cost in 20 years? Inflation, does that mean growth or decay, guys?
Growth.
That is a growth, because inflation means that it's getting bigger. So what is my A term? Is there anybody? Nobody's in 39. Who's 32? Is that empty one over there? Okay. 29. Initial value. $96.50. My B, this is growth, so that's going to be 1 plus what? Who's 15? 0.018. Do you guys agree or disagree? Yeah. Agree. How many, and be honest, forgot to move the decimal over on 1.8? And so you got like this ridiculously large number, right? I did that the very first time. I forgot. Okay? But remember, even though the percentage is given as has a decimal in it, you still have to move it over. Okay? So that should give you 1.018. And X is equal to what? Who's 16? Alyssa. 20. Okay, so when we plug it all in, Y equals 9650 times 1.018 to the 20th power. You should have ended up with what? Who's number 8?
I received $137.87.
$137.87. Do you agree or disagree? Agree. Me too. Okay? Not too bad? All right. So the one thing I want to point out to you guys, in a second, I'll have you get out your homework logs. When I initially assigned the homework, I just split up the first half of the page and the second half of the page. Some of the problems on the first half of the page go with what we're doing tomorrow. So cross out tonight's homework and tomorrow night's homework and rewrite these problems. It's the same page, I just shuffled the problems around. So tonight you're doing the 5-4 worksheet, 1 through 4, 9 through 14, and 16. Tomorrow night you're going to do 5 through 8, 15, and 18 through 24. Okay, so we're actually not going to end up doing 17 at all.